Last time we were talking about the bag, okay? Now, the idea with the bag is it's going to be a little bit more general than our stacks and our queues, all right? So if we have a bag, by default, our bag really doesn't have an ordering. There's just things in it. And its implementation may be with some sort of linear collection, like an array. So obviously something will be in index 0, then index 1, then index 2. But the fact that they're in that order is arbitrary. It doesn't really matter for the sake of a bag. And if we want to make this bag idea, we're going to need a couple of things. We're going to need a way to add something to the collection, remove something, get the size, and check if it's empty. Like the other two, like the stacks and the queues we've seen before. Uh-oh, are other people not getting audio? You can hear? Okay. So yeah, we need ways to add, remove, get the size, and check if it's empty. If we're adding to the bag, well, how do we do this? Where should the thing go? With a stack, that was obvious, right? With a stack, it always, the one end, the top. For a queue, all right, it always at the back. You always enqueue at the back. And same with remove, right? Okay, all the action's happening at the top of the stack, and for queue, everything's removing from the beginning. But like with a bag, if we want to be more general, like how do we want to do this? Well, the idea of the bag is designed to be very general, and then we can kind of make specific types of bags. At least this is where I'm trying to get to. So we can have sorted bags and indexed bags. We can have other types as well. But both sorted bags and indexed bags are bags, okay? But they're going to behave a little bit differently. If we want a specific kind of bag that keeps our elements sorted based on some ordering, adding will need to be done very carefully, right? Because unlike the idea of a general bag, this specific type of bag does have an ordering, right? So the ordering of the elements will depend on some characteristic of the contents of the bag, like numbers in ascending order, strings in alphabetical order, or whatever. The elements themselves are what's determining the ordering. So let's say I have this ordered bag with 16, 23, 29, 40, 51, 67, and 88. And I want to add 58 to this sorted bag. Where does it go? How do you add it? Where should I put it? Does it go to the end? Does it go to rear? No. Where does it go? Well, whenever you add something in a sorted bag, the add has to work in such a way that it maintains the ordering, right? So I can only put it between 51 and 67 because that's the only way that the add would leave this as an ordered bag. Did I call it ordered or sorted? Whatever. There's really only one way to element. It must go where it belongs. So we cannot specify where we add things because it could break the ordering property, right? So if I say like, okay, add it to the front. Well, okay, but now it's not a sorted bag anymore. If you add something and it's a sorted bag, it's gotta be sorted. You can't put the things anywhere else. Should there be rules on restricting where we remove stuff from the bag? Well, I guess not, because I can take any of these out and the order will be maintained. So I guess unlike add with this sorted bag, add has to be done such that the order is preserved. The thing must go where it must go. Remove doesn't matter because we can remove anything and it's not going to destroy the ordering. So that's good. And then we can have indexed bags. These are going to be very similar to like the lists that you're used to in Python. They are bags, but the elements are actually referenced by a numeric position, like an index, just like arrays. So this is going to be like our Python lists. So like the sorted bag, the specific kind of bag will have an ordering, right? The element position is important. So like index 0, index 1, index 2, and so on. And the user is going to be who determines the ordering. So with the sorted bag, the element itself, like the fact that this is 58 is determining where it must go. right? Where if I wanted to add something to a specific index, well, I specify the index. And so the position of the elements are important because it's an indexed bag. And every time something is added or removed, the indices of the elements need to be updated, though. Here's what I mean. If I want to insert this light blue, this dark blue, and this black box, well, this will become index 0, right? Because if I'm inserting it to the front, it would now be index 0. If I want to put this one between 2 and 3, well, that would end up being between 3 and 4, so it becomes 4. So after the 3, because, well, the 2 just got like promoted to 3 because we had to move all of this down to make room for the light blue one. And then all the way at the end, we have our 9th. So if I insert something anywhere in here, we need to make sure the elements, like the indices, are updated accordingly. All right? Any questions so far? You're all being awfully quiet. Well, I mean, how you add, that's up to you. I would probably do something like that. But at the end of the day, it's, I mean, there's a lot of ways we could do it. And at this point, we're talking about the what, not the how. It's good that you're thinking about the how, of course. But at this point, really, all that matters is that something gets added, it goes where it belongs. That's the rule. Okay, functionality. We're going to keep our functionality of the bag very simple. We want to add stuff, remove stuff, check if something's in there, get the count of the number of things existing in the bag, see if it's empty, get the size, and then this thing called an iterator, which we're going to learn more about in topic 16, so in a couple of topics. So we'll want an iterator. But here's what we have. We've got our add, remove, our size, our is empty, and we've added 2 other things here. The check if something is in the bag, and count the number of times something exists in the bag. So imagine like if I have a bag and I'm saying like, is the number 17 in there, right? So this would just tell me that. It would probably return a Boolean. And then this count the number, like if I had multiple 17s in that list, or in that bag, pardon me, I could say like, well, how many 17s are there? And it tells me like 4. Right? That's the idea of what that is. So here is our interface for a bag. This is it. That's all it is. Public interface bag, type T, it's generic. Add an element of type T, remove an element of type T, contains is a Boolean, get count is an int, is empty, size, and then we've got this fancy iterator thing, and that's why we have this import util.iterator at the top. Again, sit tight on the iterator. We'll cover this a little later. But an iterator is this nice handy tool to make it really easy to iterate over a collection, like loop over a collection easily. But you'll notice that this is a bag. This is the interface for a bag. That's it. So here, I'm going to go and I'm going to add the bag interface to my project here, source. I'm just copying it over from the main course stuff, but here's the bag. Okay, copy, paste. Okay, bag, yeah, okay, awesome. So there, I've got my bag interface. So it's the same as that we just looked at, except I've got like headers here, comments describing what each thing is. Add, remove, contains, get count, is empty, size, and iterator. That's all a bag is. But this is just the bag. And a moment ago, I was just talking about a sorted bag and an indexed bag, right? Well, a sorted bag is a bag. And an indexed bag is a bag as well. But they're like special kinds. And the type of functionality they have kind of extends the functionality of a bag. Okay? So sorted bag functionality. What do we want to do if we have a sorted bag? Well, actually, it looks like it's basically the same. as the regular old bag. Add stuff, remove stuff, check if something is in the bag, count the number of times something exists in the bag, see if it's empty, get the size, and get an iterator. So this is all more or less the same as the regular old bag, but there's going to be some functionality specific to the sorted bag that we're going to want. Okay? We have to make sure our add methods add stuff in the proper location. So the add for a sorted bag is going to be a little different than an add for an index bag. But we might also want a couple of other methods, like remove the first element, remove the last element, because why not? Maybe, you know, if I have like a sorted collection, maybe I always care about getting the thing at the front, right, with the smallest value. Or similarly, I always want the thing with the biggest value, right? So remove first, remove last would be a reasonable method. And check first and last elements as well, but leave it in the bag. So this is kind of like peek and front, right? So our sorted bag needs all this stuff. But we also want a couple of other things. So what I'm doing now is, oh, pardon me. What I'm doing now is why does this look the same? It shouldn't be, well, whatever. I'm going to write another interface. Okay, public interface sorted bag. It's a bag, but you know, the sorted bag, it's generic. But you'll see this new keyword here, extends. Now, before we saw implements, right? If I see, where's the queue? Oh, linked queue, right? We've seen the implements keyword here. Linked queue implements queue. But now we're seeing this other one called extends. Oh. So public interface sorted bag extends bag. What this is doing is it says, okay, inherit everything from the bag. Basically, everything that's in the bag is going to be in the sorted bag along with these as well. So a sorted bag has remove, contains, get, count, is empty, size, iterator, and remove first, remove last, first, last. So let's go to I'm going to copy that interface over as well. Where's my sorted bag? Index bag, sorted bag. Yes. I don't know if the add's necessary there, but whatever. Here we go. Okay, paste it. Yeah, paste it. Okay, great. So public interface sorted bag extends bag. So what this is saying is a sorted bag is a bag. It's kind of like I copy all of this, Control C, and like paste it there. That's kind of like what I'm doing here. I'm gonna undo that though. So the sorted bag has everything a bag has, in addition to all these other things that we're including. Isn't that kind of cool? So we are inheriting. This is the idea of inheritance. The sorted bag interface inherits from a bag. So if I come along and I want to implement a sorted bag, kind of like how I implemented a queue, right? If I go look at my linked queue, because I'm implementing a queue, I must implement all of the methods defined in queue. Where now, if I go to implement a sorted bag, I have to implement everything in the sorted bag. That also includes everything from the bag though. So I have to basically, ultimately implement both. I hear a boop. Okay. Are you extending the interface or the method itself? I'm only extending the interface. So, can you extract a specific method and call upon those methods as if they were in... I'm not sure I understand that question. Okay, the first question, I'll hit the first question. The second question I don't understand. So, We're extending the interface. There's no functionality here. It's basically like I've just included all of the methods that must be defined, all of the abstract methods that must be defined if I'm implementing a bag. But we're not implementing a bag. We want to implement a sorted bag. And the sorted bag has the things that the bag has and the sorted bag stuff. And the reason it has the stuff the bag has is because it's extending the bag. And here, let me show you real quick. Here's what I mean. So sorted bag interface is, whoops. All right, I'll let you retype that. So watch here closely. I'm going to create a new class. This is a test, okay? Obviously, this is a test. It's not overly helpful. But if I come along and say this is a test, oh, and it's generic, and I say implements a sorted bag of type T. Great. Now this is angry because, I'm not implementing all of those methods that I must implement. So if I do this and I say implement methods, look, it's saying, oh, okay, well, I have to implement all the stuff from the bag, remove contains, get count is empty, size, the iterator, and all the stuff from the sorted bag, the add, remove, first, and last. And also this stuff from java.laying.iterable, which is a consequence of this, which is some magic words for the iterator. Again, more on that in a couple of topics. But if in here with this is a test, if I do this, because I'm implementing a sorted bag, and the sorted bag extended the bag, I have to, if I want to make something that is a sorted bag, it must implement all of these things. So I say, okay, boom. Remove contains, get count is empty, size, iterator, add, remove, first, last. So all of these, I guess the add, were from the sorted bag. And if I hover here, I say, oh, implements method add in sorted bag. If I hover over like size, this says implements method in bag, which is kind of cool. Okay. Okay. So you can only extend an interface, not a class. Okay. You can extend a class, but that is really risky. And we're going to, look, I'm going to hit this real quick here. In the inheritance topic, which is the next topic, okay, we talk about inheritance, all right? So we have object bag, sorted bag, index bag, right? Terminology, blah, blah, blah. And here's like the inheritance hierarchy of Java as itself. Polymorphism, okay, we cover all this stuff. Now, there's an aside on inheriting from concrete classes. And this is the joke. This is kind of like a famous joke about when object-oriented programming popped up. This is the sales pitch. Okay, we're gonna implement all this stuff. We're gonna extend other classes and all that. But what ended up actually happening was this. It became a nightmare of just what is going on. So you can extend a concrete class. You can extend like the actual class itself, like an implementation, okay? But it tends to be terrible. And this little aside goes over an example of why that's a terrible idea. It's risky. It's risky. Your code will work, but you are destroying the niceness of your code if you do that a lot of times. Again, I'm speaking in general. There are, of course, exceptions to what I'm saying, but yeah. So that's okay, not a class, okay. We're just implementing the methods from the original interface and then adding some, right? Well, it depends on which part you're asking. Here in sorted bag, we're not implementing anything. We're extending the bag by saying if you want a sorted bag, it's got to also have, your add, remove first, remove last, first and last. But then in my example here with this is a test, if I'm saying if I'm implementing a sorted bag, I have to implement everything from bag and sorted bag. because sorted bag, extended bag, which then means if anything implements a sorted bag, it also must implement the bag. I know it sounds like I'm saying a lot of like connect these dots here, but that's not what's happening. Let me see if I can draw this, okay? Imagine for a second we have a bag interface. Okay, this is just the bag. This is just the interface. See, and it just defines some methods in it. Okay, and you'll notice that these are empty, right? There's a white background because it's just the interface. That's what I'm going with here. So let's call this the bag part. I'm hearing a lot of boops. I just want to make sure. Okay, we're extending the interface. So here's the bag. But then I also came along and I wrote the sorted bag part. Okay, which also had a couple of extra bits in it, right? Had, you know, a couple other methods that would have to be implemented. Now, if you are thinking, okay, so this is the sorted bag part. But that's not quite right. All of this is a sorted bag. Okay? So when I come along and I implement this, if I want to implement a sorted bag, I need to come along and implement everything. Oh, I guess I want my background to be blue as well. I need to implement everything from the bag and sorted bag because the sorted bag is the bag plus its stuff. All right, so sorted bag interface is bag interface plus extra method. Yes, yes. How does that work? How does what work? Can you, oh, okay, that's with the class stuff. By extending the class, do you mean adding methods that aren't in the interface? When I said extending the class, like if I'm extending the interface, so unless you're talking about the class extending like concrete classes, which we're not going to talk about that right now. I'm just going to think of it almost like we're appending the methods to a new interface. No, that's exactly how that is a good way of thinking about it, right? Like, oh, the sorted bag has these bits appended to it, in addition to everything that else that was there. But of course, you got to remember too, in a moment, we're going to, whoa, that's not what I want. In a moment, we're going to come along and implement a, let's see, back. No. Shoot. White. Pink. We're going to do this stuff. And all of that will be the indexed bag. Because an indexed bag is going to get everything from a bag. It extends a bag. Plus the indexed bag stuff. So they're both bags. Bags are at the root of what they are, but a sorted bag is not an indexed bag. But a sorted bag is a bag, right? So all sorted bags are bags, but not all bags are sorted bags because they might be indexed bags. Sweet. What about the index sorted bag? Well, we don't have an index sorted bag. We've just got, if you want to implement it all, well, you need a new interface for that. All right. Okay. So you will notice that despite wanting all the functionality of the bag, we don't write them in the interface. That's because we extend it. The extends keyword mean that we will inherit all the functionality from the class we are extending, the interface in this case that we're extending. Bag is being extended. So Just like Bilbo said, it's like we're appending. This means that although we did not write the functions from the bag interface in the sorted bag ourselves, they are still part of what make up a sorted bag. And if you try to implement a sorted bag without implementing all the functionality from the bag, it's not going to work. That's what IntelliJ was whining about over here, right? When I said, like, if I don't include all this stuff, it's saying like, hey, you didn't implement. So if I implement, it's going to want all the stuff from the bag as well. So remove, contains, get count, for example. That's from the bag interface, and I can even tell in IntelliJ. I can hover over this little eye with the arrow that says implements method remove in bag. But if we go down to first, implements method in sorted, which is cool, right? When in doubt, relate it to Python last semester. That's risky. All right, an idea is inheritance. Okay, the idea of inheritance. The idea is inheritance. This is a typo. Someone should go make a GitHub issue about this typo or go fix this typo. The idea of inheritance will be discussed further later. Okay. All right, indexed bag. So similar to a sorted bag, an indexed bag will make use of inheritance to get all the functionality for bags, but we'll also want some special stuff for the indexed bag. Stuff to be able to specify the indices in the data structure, because that's a big point of the index bag. You all are getting carried away here. All right, so public interface indexed bag extends bag. So we have add, our regular old add, but then we could say add something, like we can specify an index that we are removing from, or we are adding to, right? So we've got a general add, that probably is gonna be like append it to our bag. But add at a specific index lets us specify which index. So if I say add at index 1, well, this new element better be at index 1, and the thing that was at index 1 is gonna have to move on down the line, being index 2. And similarly, we have a set. So this isn't adding something, but it's saying go to a specific index and change what's there. We've got a get at a specific index. We have a remove, but mind the difference in functionality though, because if we go back up here and look at the bag, the regular bag, we have a remove where we say remove element. But yeah, notice that the thing that we are removing, the parameter is the element that we want to remove, where in the index bag, we are actually specifying an index that we want to remove. So it's kind of neat. And then index of is a nice method that we can say, okay, well, which index does the element 17 exist at? And it might say, oh, index 4. I don't know. Okay, so now I'm going to go back here and yeah, and then there's index bag. Copy. Paste. So here's our index bag. So again, if I go back here, let's go and change. No, this is a test wasn't supposed to be implementing a sorted bag. It should be an indexed bag. Now, if I want to implement these methods, I need everything from the bag. Remove, contains, get count is empty size, the iterator. But everything also from the index bag. Add, set, get, remove, and index of. So yeah, okay, boom. Now I would need to go along and implement these things if this is a test, was actually going to be an implementation of an indexed bag. And that's just, like, that's it. And you can go right here. If you click these, it'll download the 3 files we just talked about. The bag, index bag, and sorted bag. And yeah, that's that. That's the idea of a bag. Now, of course, we haven't implemented anything yet. We are just saying, okay, a bag, great. We know what an index bag is. We know what a bag is. We know what a sorted bag is. And if I wanted to come along and implement an indexed bag, I have to implement everything that makes an indexed bag a bag in addition to everything that makes it an indexed bag. Wait, what's the difference between index bag and sorted bag? I didn't quite get that. Just the sorted bag, we just want, whenever we add something, I mean, the difference is like just in the interface actually. So the sorted bag is everything a bag is, but we have like a remove first, remove last, first, and last. And our add is going to be like specifically to where we are, where we are, we add something, but of course we don't specify where we add something in a sorted bag because the data needs to go, like if in this example back up here, if I'm inserting 58, the 58 has to go where the 58 goes. I don't get to say, oh, 58, go to where the 23 is, because that wouldn't work. But alternatively, with an index bag, maybe I do want to specify where something goes, like add to the specific index this thing. So what's in here and how they work, how they would work, will be different between the index bag and the sorted bag. Can a bag hold? Yeah, why not? You can have a bag of bags because the thing of type T can be a bag. Yeah, no worries. See, I don't know if, yeah, a bag of bags, you could totally have a bag. You have a bag of bags of bags for all I care, because it's generic. You can have queues of queues. You could have bags of queues of stacks of bags of queues of stacks of bags of queues of bags of queues of stacks of bags. You could do that. I don't know why you would, but you totally could if you wanted to. Bagception, there you go. All right, so that's the idea of the bag. But of course, a bag of bags is like a list of lists. Kind of, yeah. Okay, so yeah, that's the idea of the bag. So before I jump into the array bag implementation, where we'll go and actually implement the bag, first we're going to talk a little bit about inheritance. So, just kind of talked about that, right? Inheritance. It's a way to derive a new class from an existing one. So this allows us to inherit functionality from the original class. So imagine for a second we have something like a vehicle class. And you know, an aircraft and a bus are both vehicles, right? So maybe for whatever reason, I'm writing this code and there's some code in the vehicle class, or you know, assuming it's an interface, right? So we have this abstract class, vehicle, that has some methods in it that are great that the aircraft needs, and also the bus needs. So why don't we have this like parent class that's a vehicle, and then our aircraft can extend vehicle and also have whatever it needs, and a bus can extend vehicle and also have whatever it needs as well. And we could keep going down, right? Like we could have a 747 that extends an aircraft, that extends a vehicle. So 747 is an aircraft and is also a vehicle, in as much as it is also a 747. But a helicopter is not a 747, but it's an aircraft and a vehicle. A helicopter and a Greyhound bus are both vehicles, but, you know, one's an aircraft, one's a bus. So this is the idea. Word of warning, though. Do I have a... No, I don't have a warning here. Sometimes we tend to get a little carried away with drawing the parallels between real life and our software. Because you can look at this and be like, yeah, that makes perfect sense in real life, like a vehicle, an aircraft, and whatever. But just because it makes sense in real life doesn't mean it naturally makes sense for your code. So just a word of warning there. This probably won't really come up except for the aside, but anyways. So notice how the top element is the most general of all the things included. As you move down, they get more specific. But as you move down, the things are still a type of the element at the top. So in our bag example, a sorted bag is a bag. Now, I've said this before, but you may have missed it. In Java, even though we never actually have to write extends object, everything extends the object class. And the object class is the parent class of everything. Anything and everything is an object. So whenever you go implement any class out there or interface, or write the interface, you are effectively also extending the object class. Meaning we inherit things that exist in the object class. Some of those things, though, that we... Hold on. If I go... Here's the object class, okay? Let's have a look at some of the methods in here. Okay, get class, okay. Hash code, okay. Equals. Clone, whatever. ToString, look at this, get class dot get name at integer 2 hex string of the hash code. Notify all, wait. So there's a couple of extra things here too. But there are a bunch of methods in here. And if you look at, like, let's look at the ToString. If you ever wrote a class without writing your own ToString, you've seen this get run. You've seen, like, student object at 7B4219998FD1, right? Like, you've seen that printed out. If here, for fun, I'm going to write, this is a test. Okay, that's it. This is a test class, has nothing in it. All right? If I go to lecture 1 and I say this is a test, a equals a new, this is a test, this is rather simple. I mean, there's nothing there. But look, I can say, this is a test.ToString. In fact, I won't even write the ToString. Oh, no, A. Because it'll do it automatically. And if I hit run, give it a second, we see this is a test at 65AB7765. Because we just called this is a test's ToString. And you look in this class and you see no ToString here. So how on earth could that be? Well, it's because we inherited the one from object for free. It calls this one because it's the parent class. In the same way that if I was implementing an indexed bag, if there's a parent class, well, I guess now we're talking about concrete classes being inherited. But yeah, if the parent class has get count, I don't need to include my get count in my interface. If my parent class, assuming it's a concrete class, has something implemented, and I'm extending that parent class that's a concrete class, I don't need to implement it because I get it from my parent. Unless we want to do something called overriding. And you've been doing this. ToString, there. Well, this is kind of silly. Return, there, return hello world. This is ridiculous, right? But now I wrote my own ToString, which then is saying, and we don't actually need this. This is just kind of like a tag there. But now this is saying, okay, if I call ToString, I'm going to run this again. We should now see hello world, right? Which is a rather silly ToString, of course. But this ToString is overriding the one from the parent class. So if I don't define it, we inherit the one from our parent. But if we define something that already exists in the parent, well, that overrides whatever the parent would give you. And I can even see, if I hover over here, it says, overrides method in object. Cool. All right, so object bag, sorted bag, index bag. So object is at the top of all this, and we've been playing with this, and you've been extending it whether you like it or not, and you've been using their methods whether you like it or not. Real life too, but you should be careful. Okay, oh, here's another issue. Someone should go fix this on GitHub. or submit an issue or make a PR, because I don't like the comma there. Okay, so if you don't put override, you still get, no. That's just a tag. We can get rid of this. And I run, or it's an annotation, that's what they call it. You don't actually need the override. It's just there to like annotate your code. Indicates that the method declares to override a method. If a method is annotated with this annotation, the type of compiles are required to generate an error message unless... It's not important that you have it. It's just if you had it and then it didn't implement, like if I say blah, right? Blah is not something I'm inheriting ever. So I'm saying override. It's being like, this isn't overriding anything in the superclass. You're crazy. So if I gave someone code that had this annotation at the top and then that didn't actually override anything, something's gone wrong. But you don't actually need it. Okay. All right, back to, okay, some terminology. The class that is being inherited from is referred to as the superclass, sometimes also the parent class or base class. And the class that is inheriting from the superclass is called the subclass. Child class, derived class are also used as well, but superclass is the parent, child, or subclass is the child. When considering the hierarchies, these terms are relative. Okay, so a sorted bag is a subclass of bag, and a bag is a superclass of index bag, and an object is also a superclass of a bag, sorted bag, and index bag. So it's all relative. These are relative terms. Okay, the object class is the root of the hierarchy. Every class you make will inherit from the object class, like it or not. This is done automatically. You don't even need to, do not extend it explicitly. Since we inherit everything from the superclass we inherit from, this means that we get all the methods from the object class too, although we almost always override them if we're using them. And we've seen some of these, like we just talked about, the equals, the toString, and whatnot. However, we ended up overriding these methods a bunch of times. We inherited them, but then we wrote our own implementation for our needs. The inherent behavior of equal, so this is just me saying, right? The has code, that should say hash code. Here's another bug. Man, someone can make a killing on submitting some simple PRs today and get those GitHub contributions up. If we do not override these methods in our class, we can still use them, but we get the default behavior from what we inherited from the superclass, the parent. So I just went on a long rant of what we were just... doesn't override just ignore warnings? Or is that... No, there's an annotation for suppress warnings. Yeah, there's a number of different types of annotations. So here's an example of the collections hierarchy. So collections is a part of a package in Java, okay? And there's some things here. So interface, abstract class, and class. But we can see okay, well... we have a stack, which inherits from a vector, which is inheriting from an abstract list, which is also extending an abstract collection, but I'm also guessing it's implementing a list. But the abstract collection also implements a collection, which implements the iterable. Long story short, this is used everywhere, okay? And I mean, this is not on the test type thing, right? Don't look at this and be like, oh my gosh, I need to know this. No, I'm just showing you that, yeah, this is used everywhere. This is a visualization of part of Java's collection class hierarchy. Okay. You will notice there is an abstract class designation right here. An abstract class is one that is declared with abstract keyword, may or may not include abstract methods declared but with no implementation, like interfaces. So I don't know if we used this word before, but in an interface, these right here, there's no implementation. They're abstract methods, meaning there's no functionality there. Someone needs to implement them. They're not concrete. Abstract class. An abstract class may not be instantiated, but it may be subclassed, inherited from. So an abstract class may include some concrete implementation of methods that will be the same among multiple subclasses. Take Java's abstract queue class and its subclass priority queue. So we have abstract queue and priority queue. I'm going to preface everything I'm about to say as like, I'm showing you this as a, hey, this is neat. And this is not going to be something that's really going to be biting you much for this semester. I'm just telling you about it. So abstract class. Here's the abstract class called abstract queue. And then we have a priority queue. A priority queue is like triage. Okay, you come into the hospital and that person gets to go first, not because they were here before you, but because they've got a higher priority or a more important priority, whatever. So this is the concrete class. And we can look at all the methods it has. Add, clear, comparator, contains, for each, iterator, offer, remove all, remove if, retain all, split iterator, to array, whatever. But we can also go look at the abstract queue. And in the abstract queue, we have add, concrete methods. Perfect. Oh, why is this not all methods, instance methods, concrete methods? All right. We have add all, clear, element, and remove. Why are these? I feel like this isn't working quite right. Concrete methods, all methods. Methods declared in class. Okay, here we go. Oh no, declared an app from abstract collection. Okay, whatever. This right here is an abstract class. The point I'm making is we have an abstract queue. No one can come along and make an instance of an abstract queue. But within the abstract queue, it might kind of be like serving as somewhere between an interface and an actual implementation. If we go and we look here, methods declared an abstract queue. Add all, element and remove are not listed in priority queue. Add all, element, and remove. I don't see an add all. There's a remove, except this is a remove with object. Oh, I'm wondering if there's a different remove. Yeah, a remove that takes no parameter. An element that takes no parameter. So there are three methods here that are from abstract queue that aren't implemented in the priority queue class. But that's because they were actually implemented in the abstract queue class. Long story short, the takeaway of this is it's like somewhere between an interface and a concrete class. That's all that really matters for our purposes right now. What I'm saying is really there's 1,001 asterisks attached to what I just said, but not overly important right now. An abstract class is one that declared an abstract. Yeah, okay. Okay, take Java's abstract queue class and its subclass. The abstract queue has a few important concrete methods implemented with the abstract class. It also inherits a bunch from the superclass 2, which was like abstract collection or something. Yeah, abstract collection, and above that is object. So add all, clear, element, and remove. But the priority queue class, which extends abstract queue, makes use of a few of these methods, add all, element, and remove, but the priority queue also overrides a few, add and clear. If you open up priorityqueue.java file, you will not find add all, element, or remove within it since it is inherited. Whatever. Okay. And the last big thing we're going to talk about in terms of inheritance will be polymorphism. But I don't think we'll hit that today because it's kind of a big idea. That you've already been using, but I just want to make sure I give us enough time to get into that. So just I want to review the abstract class thing because I realized the explanation wasn't great, and that's partially because it's not going to matter for us right now. But yeah, it's somewhere between an interface and an actual concrete class. You can't actually instantiate it, but if you extend an abstract class, you might get some already implemented methods that you don't actually need to implement. That's all. Any questions about any of that before we wrap up today? And yeah, we'll be hitting polymorphism tomorrow. Polymorphism. All right, seeing none, stop the recording.